Hello class, we're going to look at Descartes' rule of signs today. I don't want you to be terribly concerned about this one. I want you to go ahead and do it, and we're going to practice it on homework. But there is not a specific question in our test that relates to this rule of signs, Descartes' rule of signs. The reason I'm teaching it though is because if you can understand it and master it, it reduces some of your guessing when you're solving polynomial functions. So let's take a look at what that says. So we're going to start out with the possible rational roots. So I've got p here is -6 and q is 4. So the factors of 6 plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then over here I got plus, the factors of 4 are going to be 1 and 2. Oh, and 4, sorry, forgot that one. So our possible real rational roots are going to be positive -1, positive -1/2, positive -1/4, 2, 3, 3/2, 3/4, and 6. Now, when we apply Descartes' rule of signs, it's going to tell us how many possible positive roots there are and how many possible negative roots there are. So how do we do this? Positive roots. What we're going to do is write down the degree of each of these terms here. So, or not the degree, whether it's positive or negative. So 4x to the 4th is positive. Negative x cubed is negative. 5x squared is positive. Negative 2x is negative. And negative 6 is negative. And then we're going to count the sign changes. So from positive to positive is 1. From positive to negative is 1. From negative to positive is 1. From positive to negative is 1. This is not a sign change. So we have 1, 2, 3 sign changes. So the number of positive roots is going to be 3. And if this is greater than 1, that number there, you're going to subtract 2 because it could also be that number. So it has 3 or 1 positive roots. Now, how does that help? Well, we know we have 4 roots. So we know that if this can only have 3 or 1 positive roots, and there's 4 roots, we know we have at least 1 negative root. So now can we also do the same thing for negative roots? Can we determine whether or not we know exactly what the number of negative roots are? So when this time anything that has an odd degree we're going to change the sign. So 4x4 is even and it's positive. Negative x cubed is an odd, so instead of negative we're going to make that a positive. 5x squared is an even, so we're going to keep that as positive. Negative 2x is an odd degree, so we're going to change the negative to a positive. And then negative 6 is, we're going to keep that as negative. So then we're going to look for the sign change. We've got positive to positive to positive, no change here. Then we go positive to negative, we have 1 change. Since it only changes once, we can say this has exactly 1 negative root. So now we know that we have 16 possible rational roots, and of those, one of them is going to be negative, and one of them is going to be positive, and possibly 3 that are positive. The possibility of those, if it's not 3, then it would be 1, and the other 2 would be imaginary roots. So I'm going to pick a positive number to go for, and so I'm going to do 1, and we'll do synthetic division. 4, -1, 5, -2, -6. And we'll drop the 4 and do our 8 times 1, that's 6, 6 times 1 is 6, and that gives me 0. So 1 is going to be a rational, one of the roots. This is 4x cubed times, or 4x cubed plus 3x squared plus 8x plus 6. If I set that equal to 0. So I found one positive root. I'm going to start doing some negative roots now because I know that there's one positive. There might be more, but I do know there's one negative. And I'm going to do something that has a denominator with 4 because I think that's going to be where that 4 comes in. So I'm going to pick 3/4, but I'm going to make it negative. And I know you're going to pick some things that are not going to work. I happen to pick the things that do work because I know the answer in advance, which you won't have. So I'm going to take -4 and drop that down. 4 times -3/4 is -3. That gives me 0. 0 times -3/4 is 0. I multiply that, or add that to 8. 8 times -3/4 is -6, and that gives me 0 as my remainder. So -3/4 is also a 0. Now this is 4x squared plus 8. If I set that equal to 0, I'm going to use the square root property, and I'm going to subtract 8 on this. Let me go with a different color to let you see the different work. So 4x squared equals -8. I'm going to divide by 4. So I get x squared is equal to -2. And I'll take the square root of both sides. And so x is going to equal positive or negative I square roots of 2. So that's my other 2 roots. It wasn't positive, it's imaginary. So there's 1, 2, 3, and 4 roots.